Hello friends, welcome to my channel. In this video, I will cover most important solved questions from production, which videos are previous Coal India questions, Coal India 2017 questions, SSC, JEE, IES, GATE questions. They are very important for upcoming RINL questions, RINL MT and Isro Scientist and Technical Assistant, SSC, JEE, and for IES and GATE. This is part 3. Question is assertion A. Forging dies are provided with taper or draft angles on vertical surfaces. Is it true? It facilitates complete filling of die cavity and favorable grain flow. No, it's not for complete filling and favorable grain flow. So this is false statement. A is true, R is false. C is our answer. This is GATE question. In Isro also they may ask this type of questions, but they won't provide you calculator. In open die forging, a disc of diameter 200 mm and height 600 mm is compressed without any barreling effect. The final diameter of the disc is 400 mm. The true strain is how much? So, true strain we have to calculate. True strain formula is ln final length divided by initial length, or ln initial area divided by final area, or area is pi by 4 d square ln pi by 4 initial diameter square divided by pi by 4 final diameter square. Pi by 4 cancel, 2 ln di by df, initial diameter divided by final diameter. So 2 into ln initial diameter is 200 mm divided by final diameter, it's 400 mm. So 2 into ln 1 by 2. ln 1 by 2 you have to remember, it's minus 0.69. So final answer is 2 into ln 1 by 2. It's minus 0.69 into 2. You will get minus 1.386. C is our answer. So least 1 and least 2 matching. Riveted joints, it's following A with 3. So you can cut C and B. Then welded joints fusion, B with 4. B with 4. A you can put. Final answer is D. Leaf spring, C with 1. Nipping, correct. Knuckle joint, angular movement, D2. D is your answer. A forging method for reducing the diameter of a bar in the process making it longer is termed as. In Isro also they ask this question. Fullering, it's fullering, reducing the diameter. If here instead of reducing, they will ask increasing diameter, then your answer will be offsetting. So both you have to remember. In fullering, diameter is reducing, and in offsetting, diameter is increasing. Consider the following steps involved in hammer forging a connecting rod from a bar stock. From bar stock to connecting rod. We know final operation is trimming. So 2 should be at last. Here 5 is, so A will cancel. C, here 1 is available. Blocking is semi-finishing operation. Last is 3, finishing. No, before trimming we will do finishing. So only B is our answer. We can check this one. Fullering, yes, correct. 4, then 5 is edging. Then 3 is blocking, semi-finishing operation, then final finishing 3, then trimming. So B is your correct answer. This is a complete flow diagram from bar stock to connecting rod. Steps are: first is fullering, then edging, then bending, drawing out or cogging, then flattering, then blocking. Already discussed, blocking is semi-finishing operation, then finishing operation, then trimming or cut off. This is SSC and PSU question. In forging operation, fullering is done to already discussed. Draw out the material. Consider the following operation involved in forging a hexagonal bolt from a round bar stock whose diameter is equal to the bolt diameter. So, hexagonal bolt we will do from round bar. First we will do flattening, then we will do offsetting. Offsetting means we will increase the diameter, then swagging. Swagging is rotary forging operation or radial forging. Sometimes they will, in some books they will mention as radial forging operation. Then cambering. Cambering is final operation. So 1, 2, 3, 4 from option A is our answer. This is also asked in PSU. In CL or HAL they ask this question. In drop forging, forging is drawn by dropping the die with hammer at high velocity. Drop forging is used to produce small components. Then matching. All examples are very important. Investment casting. Investment casting, it's turbine blades. Then die casting, it's carburetor body. Then centrifugal casting, hollow cylindrical parts, cast iron pipes. Then D, drop forging, connecting rod, yes, 3. Then extrusion for tube making we are doing, or galvanized iron pipe. Then cell molding, it's for turbine rotors, 1. The forging defect due to hindrance to smooth flow of metal in the components called as lap occurs because corner radius provided is too small. B is our answer. Which one of the following is the correct statement? Extrusion is used for manufacturing of seamless tubes. For seamless tube we are not using extrusion. Then extrusion is used for reducing the diameter of round bars and tubes by rotating dies which open and close rapidly. This one already discussed. Swagging or rotary forging. This is also very important. Swagging or rotary forging or radial forging. Extrusion is used to improve fatigue resistance of metal by setting up compressive stresses on its surface. This is short pinning. Short pinning we are giving increasing fatigue resistance by setting up compressive stresses. Extrusion comprises pressing the metal inside a chamber to force out by high pressure through an orifice which is shaped to provide the desired form of the finished part. Yes, D is our answer. This is very important for all examination in PSU, then SSC JE, Isro also. The extrusion process used for the production of toothpaste tube, it's impact extrusion. So 3 only. Metal extrusion process is generally used for producing uniform solid section. This is correct. Then uniform hollow section. This is also correct. Uniform solid and hollow section. This is the best answer. Bearing solid and hollow section. This is drawback. Drawback of extrusion process. You cannot produce bearing solid and hollow sections. It's very difficult produce bearing solid and hollow sections in extrusion process. Matching list 1 and list 2, connecting rod, already I told. Connecting rod means forging. So you can cut B and D. Pressure vessels welding. Pressure vessels are boiler water wall panels. For joining water wall panels we are using welding process. In between tubes we are providing fins. For joining the fins and tubes we are doing welding process. And then machine tool beds, it's casting, collapsible tubes, extrusion. So from option A with 3, B with 1, A is our answer. C with 4, C machine tool beds, casting, collapsible tube, D it's extrusion. What does hydrostatic pressure in extrusion process improve? It improves ductility. Less ductile material also we can produce. We can, in a hydrostatic extrusion process, less ductile material also we can use for making components. So it improves ductility. Which one of the following processes is wire drawing process? Compressive. This is for coining process. These are very important. And wire drawing, it's tensile stress. Shear, this is for blanking or punching operation. Blanking and punching operation, shear is important. So from wire drawing already discussed, tensile force A with 2, so you can cut A and D. Here A with 4, so you omit these two. Then extrusion is compressive force B with 3, so C is your answer. Then blanking already I told, shear force, C with 1, correct. Bending with spring back, yes, C is our answer. List 1 with list 2. Malleability to produce thin sheets, cold rolling. A with 3, then hardness, indentation or scratching. 4, then resilience, impact loads, resilience and toughness, both are for impact loads. Isotropy, its direction. A wire of 0.1 mm diameter is drawn from a rod of 15 mm diameter. Dies giving the reduction of 20%, 40% and 80% are available. For minimum error in the final size, the number of stages and reduction at each stage respectively would be how much? So from each option we will take, we will calculate minimum error in which option we will get, that will be our answer. So data given are final diameter is DF is 0.1 mm, original diameter, initial diameter is 15 mm. So in A, 3 stages and 80% reduction for all 3 stages. So in option A, final diameter is initial into 80% reduction. So 1 minus 0.8, 3 stages. So 3 times multiply 1 minus 0.8, 1 minus 0.8. If you calculate this one, you will get 0.12 mm. So error E is given 0.12 minus given 0.1 mm, 0.02. This is your error in case in option A. For option 2, 4 stages, 80% reduction for first stage, 3 stages, then fourth stage 20% reduction. So DF is 15 into first 3 stages 80% reduction. So 3 times you multiply 0.8, 1 minus 0.8, then fourth it's 20% reduction. So 1 minus 0.2. If you solve this one, you will get 0.096. So error in this case is 0.1 minus 0.096. Error you will get 0.004. And for option C, 5 stages and reduction of 80% in first 2 stages, then third and fourth stage 40%, then fifth stage 20% reduction. So DF is 15 is initial into first 2 stages 80%, second one 0.8, third one 1 minus 40%, so 0.4, fourth one also 40%, then fifth one 1 minus 0.2. If you solve this one, you will get 0.1728 mm. So error is E is 0.1728 minus given is 0.1, so 0.0728. Error is this one. So least error is in second case 0.004. So answer is B. A moving mandrel is used in tube drawing. For boiler tube making, we are using tube drawing process. In India, in Pune, one company is there, Indian Seamless Metal Tubes. He is using this process for making of tubes, boiler tubes. Jindal Steel Works also, they are producing. BHL also producing. Then outside India, POSCO, Tenaris, some Japanese companies also they are producing, Chinese also they are producing. So this is very useful process for tube drawing. This question is from sheet metal operation. Best position of crank for blanking operation in a mechanical press is it's 20 degree below top dead center. A blank of 30 mm diameter is to be produced out 10 mm thickness sheet on simple die. If 6% clearance is recommended, then the nominal diameters of die, this would be die and punch are respectively how much? So first some basics you should know. This is very important. For blanking and punching operation, if operation is blanking, shear is provided in die. If operation is punching, shear will provide on punch. We will provide shear in punch. And if operation is blanking, clearance, for blanking operation, clearance we will provide in punch. And in punching operation, clearance we will provide in die. So here in this question, blank of 30 mm diameter is to be produced. So 30 mm diameter disc is our requirement. So this operation is blanking operation. Operation is blanking operation. If hole they will desire, then operation will be punching operation. But here 30 mm diameter is our desire, so it's blanking operation. So shear will give in die and clearance in punch. So our blank dia is equal to our die dia. But if operation is punching operation, then blank dia it should be punch dia. Then punch dia we have to calculate. So blank dia equal to die dia, it's 30 mm given. Then punch dia is die minus 2 into clearance. Die is 30 minus 2 into clearance is 6% of thickness. So 6 by 100 into thickness is 10. It's 0.6. So 30 minus 2 into 0.6, it's 1.2, 28.8. So from option, diameters of die and punch, D is our answer. This one already discussed. In blanking operation, the clearance is provided on, operation is blanking, so clearance on punch. If operation is punching, then clearance on die. In a blanking operation to produce steel washer, the maximum punch load used in 2 into 10 to the power 5 Newton. The flat thickness is 4 mm and the percentage of penetration is 25. The work done during this shearing operation is how much? So we know work done is force into our thickness is 4 mm, then penetration is 25%. Thickness into penetration in percentage. So force is 2 into 10 to the power 5 into 4 into penetration 25%, and 4 is in mm, so divide 10 to the power 3, 200 joule. A is our answer. Question is, a metal disc of 20 mm diameter is to be punched from a sheet of 2 mm thickness. The punch and die clearance is 3%. The required punch diameter is how much? So disc is our requirement. So operation is blanking operation. Blanking operation. Clearance on punch. So blank dia equal to blank dia or disc dia is diameter of die dia. It's 20 mm. Then clearance is 3%. So then punch dia is die dia minus 2C, 2 into clearance, 20 minus 2 into 3%, 3 by 100 into thickness is 2. So if you solve this one, 25, it's 20 minus 0.12, you will get 19.88. A is our answer. This one again asked in gate examination. Blanking operation, clearance on punch. C is our answer. For die, operation is punching. The cutting force in punching and blanking operation mainly depends on, already discussed, for blanking and punching, shear strength is important. So B is our answer. See, gate question. 50 mm diameter disc is to be produced out. So operation is blanking operation. Punched out from a carbon steel sheet of 0.1 mm thickness. The diameter of punch should be, so punch dia is die dia minus 2 into clearance. Here in this question, clearance not mentioned. So none of the above. D is our answer. This is Coal India 2017 question. This question is also useful for upcoming exams. In turning tool, crater wire occurs in crater wire. It's in rack face. But for flank face, if they will ask, instead of crater wire, if they will ask flank wire, then your answer will be flank face. And mechanism also very important. For crater wire, main mechanism is diffusion, and for flank wire, main mechanism is abrasion. This mechanism also very important. This is Coal India 17 question. What is the coordination number for simple cubic structure? Coordination number is the number of nearest atoms which are directly surrounding a given atom. So for simple cube, 6 is your answer. This is for BCC, body centered cubic, and 12 is your face centered cubic. All three are important. In resistance welding, the voltage supplied is resistance welding. Heat generated is I square RT VI. Sorry, it's I square RT is I square RT. Current is the major factor. So high current and low voltage. So 1 volt. This is our answer. This is the end of part 3 video. Part 4 onwards, other Coal India questions I will solve in part 4. Coal India, SSC and IAS questions again I will solve. In this series around 300 to 400 questions I will solve. These are very useful for all examinations. Thank you friends. Thank you for watching my video. Thank you.